Hello and welcome to Zig's Math Lessons. I'm your host, Zigglebeit B. Stunk. This channel is only for the best science, technology, engineering, and mathematics students. I'd recommend that you watch these videos with pencil and notebook handy and maintain the policy that if it's in the video, then it goes in your notes. In addition to that, any serious math student must memorize their times tables. Now let's begin. The graphs of the parent functions. So we're going to learn some graphs here. Let's start with grade 9 lines. That's the line y equals x. It's a line that slopes up through the origin. You need to know this so that if a math person says to you, consider the line y equals x, and you don't have a picture in front of you or a book, you can think of this line y equals x. It looks like that. Consider this line, y equals negative x. It's a line that slopes down through the origin. The one on the left, this one, slopes up through the origin, while this one slopes down through the origin. We can see by the fact that the coefficient on x is 1, that the slope here is 1, because the slope is the coefficient on x, as in mx plus b. But we could pick any 2 points on this line and confirm this. There's a point, the origin. Here's another point, the point 3, 3. And rise over run, rise 3, run 3. Well, 3 over 3 is 1. So the slope is in fact 1. Doing the other one, again, I could choose any point on it. I'll choose the origin. And how about the point 3 minus 3? Choose that point. Rise over run. So rise in this case is dropping, so it will be negative 3, and then running 3. So the slope here is negative 3 over 3, and that's negative 1. The slope is negative 1. As long as we're talking about lines, let's just review the basics of lines from grade 9. If y equals a number, it's a horizontal line, like this one. If it's x equals a number, like x equals negative 1, then it's a vertical line, like this one. All the other lines are y equals mx plus b, where m, the coefficient on x, is the slope. Rise 2, run 1, rise 2, run 1, because that's what 2 is. And this number over here is the y-intercept. So in this case, that would be negative 1. And we can say that it intercepts the y-axis at negative 1. A review of grade 9 lines. Let's take a look at some grade 10 graphs. Y equals x squared. Okay, so we can choose anything for x as long as y is the square of that value, because y equals x squared. So 0 squared, 1 squared, negative 1 squared is 1, 2 squared is 4, and so on. Putting these points on a grid, we get 0, 0 is there, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9. Let's check this. 1, 2, 3, 9, and negative 3, 9. Join them together, and we have y equals x squared from grade 10. It's a parabola. It opens up. It's not linear. You can't draw it with a ruler because it's a curve. It has this thing called a vertex at the extreme value. In this case, the vertex is the origin. Something you might notice about this graph is when you displace yourself from the origin horizontally, you go up the square of the amount that you displace. Go over 2, you'll go up the square of 2, which is 4. And y equals negative x squared, it will be the exact same curve, but changed in that all the y values are now negative, because it's going to be the negative of x squared. So 2 squared is 4, for example, so we take the negative of that. These are the points from the table of values, putting them on a grid: 0, 0, 1, negative 1, negative 1, negative 1, 2, negative 4. Now I'm taking for granted that a student in grade 11 knows that 2, negative 4 is 2 over here and then 4 downwards, right there. And then negative 2, negative 4, 3, negative 9, and negative 3, negative 9. Join them together, label your graph, y equals negative x squared. It's a parabola. It opens down. It has a vertex at the origin. And now the first grade 11 graph, we come to y equals root x. Now, I could choose anything for x on my table of values to graph this, but I chose numbers that I know the square root of. Of course, I couldn't choose a negative number because we can't take the square root of negative numbers. So these have to be non-negative numbers, and they have to be numbers that I know the square root of. So I just picked 0, 1, 4, and 9, because I know the square root of 4 is 2, for example. So y equals square root x. If x is 0, y is the square root of that. If x is 1, y is the square root of that. If x is 4, y is the square root of that. If x is 9, y is the square root of that. These points are put on the grid: 0, 0, 1, 1, 4, 2, 9, 3, joined together, and it's a half a parabola that opens to the right. Y equals root x. A half a parabola opens to the right must have a vertex. Let's take a look at y equals negative root x. It's going to be similar. Again, I chose numbers that I know the square root of, and they have to be non-negative because they have to be put underneath a root sign. So y is going to equal the negative of the root. So if x is 0, y is, well, the negative of root 0 is still 0. If x is 1, y is the negative of root 1. Root 1 is 1, so negative 1. If x is 4, y is the negative square root of 4, which will be negative 2, and so on. If x is 9, y is the negative root of 9. The root of 9 is 3, so negative 3. These points are put on the grid: 0, 0, 1, minus 1, 4, minus 2, 9, minus 3. Join them together, and we have y equals negative root x, the bottom half of a parabola that opens to the right. Since it's a parabola, it gets a vertex. We could put the previous two graphs on the same grid and have a look. Well, y equals root x is the top half of a parabola that opens to the right, while y equals negative root x is the bottom half of a parabola that opens to the right. And if we just put them both on the same grid, we have a whole parabola that opens to the right. Y equals plus or minus root x. It's a parabola, it opens to the right, so it has a vertex. Interestingly enough here, this whole parabola that opens to the right is not a function, because we can draw a vertical line that goes through it more than once. That vertical line goes through it more than once, so it fails the vertical line test. It's not a function, but it is a parabola. Moving on, let's take a look at the graph of y equals 1 over x. Okay, so this is new. I wonder what this is going to look like. We can pick numbers here as long as we can go 1 over that number. So we can't pick 0 because you can't go 1 over 0. So we can pick numbers. Let's just start with 1, 2, 3, 4. So y will be 1 over 1, 1 over 2, 1 over 3, and 1 over 4. That's easy enough. The thing is, we can also pick small numbers. I went 1, 2, 3, 4. I could pick numbers less than 1, like a half, for example. Now, y has to be equal to 1 over a half. Because x is a half, y has to be 1 over a half. Let's see what this looks like in our rough area. 1 over a half means we're dividing by a fraction, and so the fraction that we're dividing by has to be inverted, and now it's multiplied. 1 times 2, which is 2. So 1 over a half is actually 2. We could put a third in for x. This is just a function machine. We could feed it a 1/3 value, and 1 over a third is 3. We could feed it a quarter, and 1 over a quarter is 4. And I did this one here as well. 1 over a quarter, 1 times, invert the quarter, you got 4 over 1, so it's 1 times 4, which is 4. So all of these points are going on our graph. Let's take a look at them. There's 1, 1, there's 2 1/2, there's 3 1/3, there's 4 1/4. Then we have to do a half 2, so we have to be careful and go a halfway to 1, 2, a third 3, and a quarter 4. So these points are all going on our graph. Great. How about, I wonder if we could sub in negative numbers. Yes, we can. We could put some negative numbers in here for x as well. That'll give us some domain on the left of the y-axis. Let's start with -1, -2, -3, and -4. Y has to be 1 over -1. 1 over -1 is -1. And then 1 over -2 is -1 over 2. And 1 over -3 is -1 over 3. And 1 over -4 is -1/4. So those points are going on our graph as well, these 4. Let's put them on. -1, -1 goes there. -2, -1/2, -3, -1/3, -4, -1/4. We can also feed this function small negative numbers that are less than 1. So we could try -1/2 or -1/3 or -1/4 and see what we get. So if I subbed in -1/2, it would be like 1 over -1/2, the same as 1 times -2, and we'd get -2. Similarly, 1 over -1/3 is -3, and 1 over -1/4 is -4. So these last 3 points are also going on our grid. -1/2, -2. Let's take a look. -1/2, -2 is going on. -1/3, -3, -1/4, -4. Now we've got points all over the place. Let's join them together in a smooth curve. And we have one graph in 2 branches. What you're looking at is just one graph. It's the graph of y equals 1 over x, but it has 2 branches. Notice a couple things about this. As this blue line goes along, it's getting closer and closer to the x-axis, but it'll never touch it. It gets really, really close, but never actually touches it. And we've got a special name for such a line. It's called an asymptote. An asymptote is a line to which a graph approaches but never touches. This blue line is also asymptotic to the y-axis. It approaches the y-axis but never touches it because x can never be 0. And we see it being asymptotic here and here. So the axes are asymptotes to the line, to the graph of y equals 1 over x. Let's take a look at y equals -1 over x. It will have the same table of values except for all the y values that used to be positive are now negative because y equals -1 over x. These used to be positive in the previous graph, but now they're negative, while these used to be negative in the previous graph, but now they're all positive because a negative turns out positive. Putting them on the grid, starting here, 1 -1, 2 -1/2, 3 -1/3, 4 -1/4, and so on. A half -2, let's be careful. 1/2 -2 is right there. A third -3, a quarter -4, and now the other ones, -1, 1, let's be careful, -1, 1, right there. -2, -2, a half, -3, a third, -4, a quarter, and now we're up to here, -1/2, 2. So -1/2, 2, negative a third, 3, negative 4 a quarter. Lots of points, join them together, smooth curve. We have one graph of y equals negative 1 over x. It has 2 branches, and they're in the top left and bottom right quadrants. For this graph too, the axes are asymptotes. Moving on. Y equals the absolute value of x. What is the absolute value of x? These funny looking brackets are called absolute value brackets, and what they mean is that y will take on the positive version of the x value. The y value will be the positive version of x. So if x was 2, well, y is the positive version of 2. If x was 5, well, the y is the positive version of 5. But if x was, say, negative 3, so if there was a negative 3 inside those absolute value brackets, if x was negative 3, y would be the positive version of negative 3. So y would be positive 3. Notice all the y values, and therefore all the absolute values, are positive numbers. And so graphing these, those are the points. That's the graph. It's the graph of y equals the absolute value of x. Notice it looks like a big V. And the negative version, all those positive y values are now negative, because y equals negative the absolute value. So we get these points instead. Join them together, label your graph, and that's y equals the negative absolute value of x. In summary, I'm going to flash up a function, and you're going to think in your imagination of what it looks like. Y equals x, it's a line sloping up through the origin. Y equals negative x, it's a line sloping down through the origin. Y equals x squared, a parabola with its vertex at the origin opening up. Y equals negative x squared, a parabola with its vertex at the origin but opening down. Y equals root x, the top half of a parabola that opens to the right with its vertex at the origin. Y equals negative root x is the bottom half of that same parabola. Y equals 1 over x. This is the single graph in 2 branches, in the top right and bottom left quadrants. So we can bring that to mind. It's got asymptotes at the axes. Y equals negative 1 over x. Same thing, except the branches are in the top left and bottom right. Y equals the absolute value of x is the big V. And y equals negative the absolute value of x is that big V upside down. I'm not really Ziegelviet V. Stunk, but thanks for watching. If you liked it, leave a like. If you like the content, please subscribe.